I just wanted to go through how these examples came about. It's easier to talk through them on paper rather than doing it any other way. So this was the object on the left, and what we did was we counted the number of squares from each point to the mirror line, so we can see that's 1. So we went 1 mark on the other side, and we put in a mark. And we did that for each point. So this bottom corner is 1 to the mirror line, so its image is 1 on the other side. This point was 3, so we had 3. This other point was 3 to the mirror line and 3 to the mirror line. And point by point we were able to do that. Same with example 2. So this bottom point is 1 to the mirror line. So we drew, or this was 1 to the mirror line, so we drew it on the other side. This was 3 to the mirror line, so its image was 3. And this was 3 to the mirror line, so it's 3 on the other side. And example 3, the first point, it was on the mirror line, so its image was also on the mirror line. This next one was 1 from the mirror line, so its image was 1. The next was 2, and 2, 2 to the mirror line, 2 to the mirror line, 1 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 to the mirror line. And that's the same for examples 4 and examples 5. Example 6, what we have is we count right angles to the mirror line. So we go diagonally across 1 square, so its image is diagonally across 1. We went diagonally across 2, so we go diagonally 2. Diagonally 2, diagonally 2, and diagonally 1, diagonally 1. Similarly with this one, we go at right angles to the mirror line, and we can see that's 1 square to the mirror line, so it's diagonally 1. It's diagonally 1, 2, 3, so 1, 2, 3 on the other side. And we went in this direction. And same with this then, we were 2 above, so we're 2 below. We're 3 above, so 3 below, 3 above, 3 below. Mark in the points, and then join the shape up using a ruler. For the next example, same process again. This time though, the original object was across the mirror line, so it was on both sides of the mirror line, but it's the same process. So we count the number of squares from each point to the mirror line. So the top one is 3 squares to the mirror line, so we repeat that on the other side. The bottom right was 3 to the mirror line, so it's going to be 3 on the other side. The last point though was 2 on this side, so we reflect it, and that's 2 on the other, and we join them up. And I've tried to shade that to make that a bit more obvious. The method for finding where the mirror line is, what we do is we join the opposite vertices, the opposite corners, the opposite points. So A corresponds with A dash, and we join a line and we put a mark at the midpoint of it. Same with D and D dash, we join them up with a line and we make a point at the midpoint. With B and B dash, we draw a line and mark it at the middle. And same with C and C dash. And the line passing through those 2 points is the mirror line, so it's this vertical line. And the vertical mirror line is 1 square on the left hand side of the y-axis. In example 5, we joined corresponding points again, so we joined A and A dash with a ruler, and we marked on the midpoint. Did the same for B to B dash, C to C dash, and D to D dash, and we marked on the midpoints, and then I joined those up and extended the line. So what we have is a diagonal line sloping upwards. This is an upwards line, because in the same way you read a sentence, you read it from left to right, you read a line going from left to right, so that's sloping upwards rather than the line from C to C dash sloping downwards. So that's a diagonal line upwards, and it passes through the origin. The origin is just the name of the point 0, 0. And the last example, again, we join the lines A and A dash, B and B dash, C and C dash, D and D dash, E and E dash, F and F dash, mark on the midpoints and draw the line. So this was a horizontal line that was 2 squares above the x-axis. A translation vector is a fancy way of describing the movement, and the way it's set up, it's kind of a mixture between a fraction and a coordinate. The top number, similar to coordinate in the first number, it tells us the horizontal direction, and the bottom number is kind of like the y value. So if we were trying to get 2, 3, that's 2 horizontally to the right, because in a set of axes the horizontal direction to the right is positive, and similarly with the y-axis the vertical direction, the vertically up direction is positive. So the top number represents the horizontal movement and the bottom number represents the vertical movement. Positive, in the same way with coordinates, would be right and up. The negative values would be left and down. So to describe 2 squares to the left, that would be -2, and 3 squares down would be -3. So if we were going 1 square to the right and 2 squares up, the top number is the horizontal direction, the bottom number is the vertical direction. Because right and up are positive, it's 1 and 2. 4 squares to the left and 1 up, 4 to the left is in the negative direction, so that's a -4. 1 square up is in the positive direction, so it's a +1. 3 squares to the right and 2 squares down, 3 to the right is a positive direction, so it's +3. 2 squares down is down 2, it's -2. 5 to the left is negative. 3 squares down is negative as well, so it's -5, -3. In this example, we're trying to describe the translations from each of these 8 different directions. So if we look at A is here and D is up here. Now the grid paper there are smaller squares, but what we're trying to do is we count the number from 1 to 2 to 3 to 4. Rather than squares, we're thinking about it in terms of units. So if we start with the bottom right corner, to get to D, we'll go across 1, 2, 3, 4, and we'll go up 1, 2, 3. So because that was right and up, they're both positive, so it's 4 and 3. A to K, here's A, here's K. So we're going to the left, which is going to be a negative number, and we're going up, which is a positive direction. So from the bottom corner to bottom corner, we'll go left 1, 2, 3, 4, and up 1, 2, 3. So it's -4, 3. J to A, here's J, we're moving to A. J is moving to the right, so it's going to be a positive number. There's no vertical movement, so to get from the bottom right corner to the bottom right corner, we go to the right 1, 2, 3, 4, 5, 6, 7. So the number is 7, and because there's no vertical direction, the bottom number is 0. B to L, B's here, L's there. We're going to the right and we're going up, so both values are going to be positive. Let's go from the top this time, because you can take any point. So we're going right 1, 2, 3, 4, and up 1, 4, 1. G to N, G's here, N is there, so it's going left and down, so we can see they're both negative. So left, let's go from the top corner here. So we'll go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then down 1, 2, 3, -11, -3. F to E, F's up here, E's down there. We're moving left and down, so again both are negative. We'll start off with the top point, and we'll go left 1, 2, 3, 4, and down 1, 2, 3, 4, -4, -4. J to C, we've gone right and down, so the top number is positive, the bottom number is negative. We go from the bottom right corner, right 1, 2, 3, and down 1, 2, 3, 3 -3. And then I to K, I's down here, K's up here, we're moving to the right and up. Both numbers will be positive. Going to the bottom right corner, we've moved 1, 2, 3 to the right, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 9. For translating A by these vectors. 7, 2, so 7 is positive, 2 is positive, that means the 7 is to the right and the 2 is up. So we'll start off with the bottom point and we'll go to the right 1, 2, 3, 4, 5, 6, 7 and up 2. So the bottom point is up here, and because the triangle is 2 wide we could draw it back 2, and then it's 3 tall, so we could draw it up 3 and then joining it up and shading it and labelling it B. We're translating A each time, so if we go from A to go 4 minus 6, that's going to be 4 to the right and 6 down. So let's start with the top point. 4 to the right is going to be 1, 2, 3, 4, 6 down, 1, 2, 3, 4, 5, 6. So that was the top point. So we go down 3, we go right 2, we join it up, shade it in, label it C. There we go. Again, going back from A to get D, it's minus 4 minus 1, that's 4 to the left and 1 down. So let's pick the bottom left point. We go right, left, 1, 2, 3, 4, down 1, and there's our triangle, label it D. To get E, minus 3, 2, we'll go left 3 and up 2. So let's go for the top point. We'll go left 3, 1, 2, 3, and up 2, 1, 2. Oh, that's wrong.